So in our next example, we are going to use some organizational tools to simplify the calculation and also take a little bit more advantage of what our calculator can do. We're going to solve x fourth plus x minus 3 equals 0. So you first take a moment to think, how else could you solve this besides an iterative method? Is there another way? Can we factor it? It won't factor. What are other ways that you can solve a polynomial? It's a simple polynomial equation. We ought to be able to solve it. It turns out many polynomial equations are very resistant to solving if they don't factor. So you learned how to factor a lot of different things and solve polynomial equations by factoring, but you didn't talk about what happens if they can't be factored. So, one thing we might consider doing is using the rational roots theorem, the P over Q thing, and consider all possible rational roots. I think there's only 1 and 3 for this one. And then you could do polynomial division and see if you can find a rational factor. But if there doesn't have to be a rational factor. And if there aren't any rational solutions, then you won't be able to factor this and solve it that way. There is something called a quartic formula, so analogous to the quadratic formula. If this was quadratic, I could just use quadratic formula. Okay, there is a cubic formula and there's a quartic formula. If this was 5th degree, there's no formula for anything beyond 4th degree polynomials. That, in fact, is a famous theorem by Fermat. It's called Fermat's last theorem because he wrote in his notebook that he had a proof that there can be no formula to solve any polynomial 5th degree or higher, and then he died and no one could find his proof. And people have been trying to prove it ever since. But there are a cubic and a quartic formula. So why don't we learn the quartic formula just like you learned the quadratic formula? I will tell you why you're not going to learn the quartic formula and you will be grateful. There's the quartic formula. Let me try and take the glare off it. There's the quartic formula, and yeah, that is the quartic formula. This is why nobody learns it and nobody uses it. Oh, that's it. See, that's all. Okay, so I want you to memorize that. Yeah, that's the quartic formula. It's pretty interesting stuff. All right, but you can see how it's practically useless. So now let's solve it using Newton's method. So I'm just going to, so one thing we need our seed values. We need to know where we're going to start with. So in the calculator, I've already put in both f and f prime. So that's one of the ways that we can simplify this work. I'm going to turn off the f prime graph and just look at the f graph because that will give us a starting point for the calculations. So this one looks like it's close to 1. This intercept is close to 1, and this intercept is close to negative 1.5. All right, so we're going to start by looking at the graph and saying x is approximately 1 and x is approximately negative 1.5. Of course, once we have the graph up here, we could just type second calc, I think it's root or something, second calc root. All right, but our purpose here is to understand how the calculator does that. How do you write a program that solves these kinds of equations? All right, so what I want to be thinking of is that my f of x here is x fourth plus x minus 3, and my f prime of x is 4x cubed plus 1. And my formula, well, I'll write the formula as part of the chart. So I'm going to write a chart to sort of track everything. So we're going to look at what n is, and what x sub n is, and what f of x sub n is, and what f prime of x sub n is. And then I'll just write up here on my column heading that the x sub n plus 1, which I'm going to put here, is equal to x sub n minus f of x sub n over f prime of x sub n. All right, and then we'll just 1, 2, 3, 4. Now, how do I know how many of them to do? The book says accurate to 6 decimal places. Well, how am I going to know when I'm accurate to 6 decimal places without knowing what the value was to start with? I will show you. All right, but first let's start filling out this chart. So So again, remembering that I have both of those functions in here. So my x sub n, I'm going to start with the 1. So we'll start with 1, and then I'll show you even better techniques for the negative 1.5. So our x sub n is 1. All right. Now I could work out f of x sub n pretty easily, but just to show you how we can take advantage of our calculator work, to get f of x sub n, I'm just going to go variables, y variables, function y1 of 1. I mean, I could work that out pretty easy there. It's negative 1, right? But just to show that you can do that. Yeah, it's negative 1. How about that? I did something funny with the decimals that I'll need to show you later. And then my f prime of x sub n, so I'll go variables, y variables, function y2 of 1. And that is 5. Could have figured that out, but didn't bother. All right, and then my x sub n plus 1 is going to be x sub n, and then it's going to be minus f of x sub n over f prime of x sub n. So that is going to be, since I'm minusing a negative, it's going to be plus 1/5. And all right, I'm not going to put that in my calculator, it's 1.2. All right, that's 1.2. All right, so that's my, that now is x sub 2. So the next thing that happens is that this is x sub 2, so it goes back to the beginning of the chart. And then I'm going to go again. Okay, so before I do that, I'm going to show you why I'm getting these weird decimals here, right? Okay, so under mode, you're normally going to be in float mode. All right, so if I'm in float mode, hey, get me out of here, get me off this crazy thing. If I'm in float mode and I do vars, y vars, function y1 of 1, it tells me the sensible thing that it's negative 1. Now, the problem is how many decimals it displays gets problematic. I guess we'll deal with that as we go along. But for now, keep in mind that you can adjust the number of decimals. Float means it puts the decimal wherever it thinks it should be. But you can select to display 0 to 9 decimals every time. All right, we'll see why that's important as we continue.